Partial sum of an arithmetic sequence. So, we've actually seen arithmetic sequences before. I just didn't classify them yet as arithmetic. Let me show you an example and a non-example to see if you guys can come up with your own definition of what an arithmetic sequence is. So here's an example. Here's a non-example. Yeah.
This one's times 2. The second one's times 2. The first one.
Well, let's first of all recognize patterns. They both have patterns, but the key is what kind of pattern is happening here. In the first example of an arithmetic sequence, what's the pattern? The pattern is adding 6. Every time we add 6. Okay? That's what's referred to as a common difference.
Well, it depends on what format you use. It could be 3x 3 times
If n equals 1, that would work, because 3 times 1 is 3, but here for 2, 3 times 2 would have been 6.
Yeah, but 3 times 3, so it would be odd. So instead of using subscript n, you would use subscript n.
M?
Yeah.
For M for what?
For odds. I used it before.
For odds. Now, it's not that this non-example doesn't have a pattern. It's just a different type of pattern. What's the pattern here? Here we're multiplying by that's what's referred to as a common ratio. And we'll study that actually in 12.3. If it has a common ratio, that's a different type of sequence called geometric. So arithmetic has a common difference where you are either adding the same number every time or subtracting the same number every time. But the key is you're adding or subtracting the same number every time. A common difference. Okay? So in general, if the common difference is some random number d, so we could be adding 3, or we could be adding 10, or we could be adding 16, doesn't matter. Whatever the common difference is, then an arithmetic sequence can be thought of as this. The first term would be a sub 1. You guys agree? Now, just using general terms here, not specific terms, what would the next term be? A sub 1 plus d. A sub 1 plus d. What would the next term be? Okay. It would, well, okay, let me write this. Wouldn't it be a sub 1 plus d? But can we write that a more simple way? Plus 2d. What about the next term? A sub 1 plus 3d. And so on, and so on. Thank you. So, the general form, a sub n, or I guess an easy way to make an explicit formula for an arithmetic sequence, a sub n is equal to a sub 1 plus Now let's see if you guys can come up with this pattern here.
N minus 1.
Exactly. N minus 1 times D. So as long as you know the first term and the common difference between terms, it's pretty easy to write the explicit formula for an arithmetic sequence. It's the first term plus n minus 1 times the common difference. Now, for those that haven't quite seen it yet or maybe a little confused on where this came from, every single one of these terms starts with a sub 1, right? This one's a sub 1 plus 0d. This one is a sub 1 plus 1d plus 2d. So why the n minus 1 times d? Well, where I'm circling right now, isn't this the third term? So if you take 1 away from the third term, that's why there's a 2d here. Right here, this is the fourth term. So n minus 1 would be 4 minus 1. That's why it's 3d. You guys seeing this? Okay, that's where this formula came from. So the first thing you're going to have to do as examples is find the nth term. Okay, what that really means is write the explicit formula. When you see that phrase, find the nth term, write the explicit formula. Of this sequence. I guess first you have to identify it as arithmetic. If it's not arithmetic, then that formula won't even work. So you really should get into the habit of considering what type of sequence you have. How do we know it's arithmetic? Common difference, right? We're adding what every time? We're adding 7 every time. So it is arithmetic. So to find the nth term means to write the explicit formula. We need to use this formula right here. A sub n equals the first term, negative 4, plus n minus 1 times the common difference, which is 7, and then we simplify. And the reason we need to simplify, you need to think back to the last lesson. If it is arithmetic, then isn't it modeled by a linear function? Okay, so we need to write this in the form of resembling y equals mx plus b. So how do we do that? Multiply what? Yeah, you distribute the 7. So it's negative 4 plus 7n minus 7. So you end up with 7n minus 11 equals a sub n. Now, this is exactly the way the book would recommend that you do this. It is not the only way it needs to be done. I actually think there's a quicker way. This is a good way, as long as you can remember the formula. That's the key, as long as you can remember this formula. It's not a super tricky formula to remember, but myself, I tend to think about it this way. If it is arithmetic, then it is modeled by a linear function, true or false? If it's arithmetic, we can use a linear function to model it. True, right? If it is linear, that means it's going to have a slope, correct? What's the slope going to be? The number that you're adding every time, the common difference. Now, you'll get better at this as you get more comfortable, but if we're taking a look at an input-output table, when n equals 1, what's the output? Negative 4. When n equals 2, the output was 3. When n equals 3, the output was 10. Now, we're going to model this resembling something like y equals mx plus b. I know you all know what the m is. It is the slope, right? But what is b? It would be the y-intercept. On this table, the y-intercept would be where n equals 0. Even though that doesn't actually exist in the sequence, there is no 0 term of a sequence. If we did extend this table to include a 0 term where n equals 0, what would that be? It would be negative 11. How do we know that? It follows a pattern. Okay, going down the table, you're adding 7 every time, right? Negative 4, then 3, and then 10. But if you're going up the table, what's that mean? You're subtracting 7. So as long as you can find that 0 term
and you know what the common difference is, what's the formula going to be?
What's the slope? 7. What's the quote-unquote y-intercept? -11. So the explicit formula is going to be y equals 7n minus 11. Is that not what we got with the formula? So it can be a little bit quicker as long as you're good about thinking those things in your head. Let's try another one. Part B. Same thing. Find the nth term. Okay, whatever that means. Of the sequence (2, -1, -4, -7).
Again, don't just assume it's arithmetic. Check it. Is it arithmetic?
What do you think? Is it arithmetic? Okay, what's the common difference then? -3. So we know that the common difference is -3. Depending on how you want to do this, you could use the book formula and say, okay, a sub n is equal to 2. That's the first term plus n minus 1 multiplied by the common difference of -3. Or you could say, all right, it's going to be modeled using a linear function, y equals mx plus b. The common difference is -3, so it's -3n. But then what would the 0 term be? If there were a term right here before the 2, what would it have been? 5. So it's going to be -3n plus 5, which is what you would have gotten from simplifying that formula there. So the nth term is -3n plus 5. Just for the sake of practice, even though it's not necessarily part of this lesson, it's part of last lesson. The students seem to struggle with this on the final exam. Write a recursive formula for this sequence. Write a recursive formula. We've written an explicit formula.
Write a recursive.
It's really easy for arithmetic sequences. Really easy. This is the explicit formula. Yeah, but we have to know the first term. A recursive formula always starts with the first term. A sub 1 equals 2, right? That's the first term. And then a sub n plus 1, the next term. Is what? How do we? A sub n. Close. We're not. There you go. We're subtracting 3. So the next term is going to be whatever the current term is, and then you just subtract 3. That would be the recursive formula. Okay. This one's a tricky one. It requires a little bit of thought. I want to see how you guys do on this one. Example 2. Find the nth term. Again, all that means is write the explicit formula. But I'm not going to give you what the sequence is. I'm going to tell you the 11th term is 52. And the 19th term is 92, and this is the key that makes this whole thing work. The sequence is arithmetic. This would be an impossible problem to solve had we not known what type of sequence we were dealing with. Still, we'd have to know whether it's arithmetic. The 11th term is 52. The 19th term is 92. Find the nth term. So come on, let's talk it out. You got it?
I don't have the working it out.
Oh.
I just worked it out in my mind.
We got to get used to talking our problems out, not just texting nasty things to your friends about people.
Sounds like a personal problem.
You got to talk your problems out.
Or you can just be positive. You can just be positive.
Or you could post bad things on Facebook.
He thinks simply. I think you're a great person.
Anybody think they've gotten anywhere? What two things do we need to write the explicit? Let's first talk about that. What's the most important thing we need? The common difference between terms. That's between each term. We know the difference between the 11th and the 19th term, but we need to know the difference between the 11th and the 12th, and the 12th and the 13th. So that's important, and we know there is going to be a common difference because it says it's arithmetic. What is the common difference? 5? 5. 5. 5. It is 5. How do we know that?
There's 40. There's 40. Like 92 minus 50 is 40, and then there's 18 between 11. Just 40 divided by 8.
Yeah, there's a couple ways that this could be found. It sounds like most of you are choosing a good way here. Between just terms of the sequence, 52 to 92, how much has passed between 52 and 92? 40. So that's a distance of 40. And how many terms did it take to do that? To go from 52 to 92, that took 8 terms. So if it took 8 terms to go 40 units, 40 divided by 8 is 5. Common difference is 5. It's 40 divided by 8. 40 is the difference in the actual terms of the sequence, 52 and 92. And then 8 is the difference in how many spots it took to go that far. 40 divided by 8. Okay, so we have the common difference. We know now that a sub n then is going to equal 5n plus something, or maybe minus something. How do we know? How do we figure out the rest of this? Yeah, we could do that. I think that's what you were both describing. Yeah, you guys are right. Here's what I would recommend. Do we know what this term is exactly initially? Probably not. But do we know a certain a sub n value and an n value to help us figure that out? We know when n equals 11, what does a sub n equal? 52. So we could use this n value and this a sub n value, plug it in to help us find that question mark. So if a sub n is 52, and then 5 times 11, plus, I'm going to call it x instead of a question mark, to make it seem more mathematical. 5 times 11 is 55. Yep, if you subtract 55 from 52, you get negative 3, so that's what that's going to equal. A sub n equals 5n minus 3. Now, it's never a bad idea just to check your formula to make sure it actually would produce what it's supposed to produce. This is saying that the 11th term is going to be 52. Would that formula produce 52 with the 11th term? 5 times 11 is 55 minus 3 is 52. Would it produce 92 for the 19th term? 5 times 19 is 95. 95 minus 3 is 92. How'd you do it?
I decided, I did A sub n, which is like A sub 1 stem, which is A sub n, which is 52. So I just did 50 times 10, and I subtracted that from 52 minus 2, so A sub n equals 2 plus n minus 1 equals 5.
Good. Came up with the same thing? Very good. Okay. Let's go on to partial sums. There is a story, and it is true. It's not just some made-up thing to make these guys seem superhuman. It is true. Where have we heard this name before? Carl Friedrich Gauss. Gaussian elimination. So he's already pretty famous for coming up with a couple of cool things. But he also dabbled in the mathematics of sequences and series. As a young schoolboy, 11 or 12, he was in a class. Teacher obviously needed a break. It was probably a school for boys, and you know how boys can be. Pretty stupid, right?
So at this time, boys are the only ones going to school.
Anyway, I was joking, but he obviously needed a break. Maybe he had to go out back and smoke a cigarette. I don't know what's going on. But no, I'm just kidding. So he gave his students a problem that he thought would take them a long time to figure out. He said, I want you guys to add numbers 1 through 100 by hand. I want you to tell me what the sum is. If you start with 1 and add all the integers from 1 to 100, he thought that would take a little while, but Mr. Gauss, the smart aleck, solved it almost instantly in a matter of seconds. How was he able to do that? He did recognize the pattern, yeah. The real story is he got out his calculator and just, no, it was back in the 18th or 19th century. No calculators. Yeah, he got out his, what is it, an abacus or something? And yeah. So this was the problem posed to these young whippersnappers. How was it solved so quickly? It is a sequence. It's arithmetic because you're just adding 1 every time. What pattern was recognized? Let's see if you guys can come up with it.
Well, you just do 100 plus, and then since 99 plus 1 is another 100, and 98 plus 2 is another 100, and 97 plus 3 is another 100, you just take 100 divided by 2, 50, and then multiply by 10. So 600.
Okay, that's essentially what it was. The end result is a little bit off, but that's essentially pretty darn close. If you start with the first term and add the last term, what's that sum? 101. If you start with the second term and add the second to last term, what's that sum? 101. Third term and third to last term is 101. Now, does this pattern continue indefinitely? Well, let's see. Eventually, somewhere in the middle, we would have a 48, and then over here we would have what? What would be the opposite of that? There would be a 50. But we'd have to add to make 101. There would be a 53 over here, and then there would be a 49 and a 52. Oh, I didn't even leave myself enough room. 48, 53, 49, 52, 50, and 50. What am I doing? 51. So we have 48 and 53. We have 49 and 52. We have 50 and 51. They all pair up to be what? 101. And how many pairs of 101 are there? So the sum of this is nothing more than 50 multiplied by what? 50 multiplied by 101, which takes much less time to solve than adding 100 numbers up by hand. 50 times 101. What is that? What's that? 5,000. 50 times 100. It's got to be more than that. 5,000. 50. 5,000.
Well, if you do 50 times 100 and
50 times 10 is 500. So yeah, it is 5,050. Dang it, that teacher had to come back from his break and say, "Oh shoot, you guys figured it out so quickly."
I wonder if he like told the whole class.
He probably did because he was a punk. He went around to every kid and said, "Hey, it's 5,050. It's 5,050."
The nerve of that guy.
The nerve of that guy, coming up with all these cool formulas. What a punk. Now, did that only work for that one particular sequence, or would that have worked for any arithmetic sequence? What if I asked you guys to add the first 10 numbers up? So 1 plus 2 plus, which really wouldn't be that hard to do by hand. Did I skip any? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what would this be? Here we have a sum of 11. Here we have a sum of 11. Here we have a sum of 11. Here we have 11. And there we have 11. 11 times 5 is 55. All right. Well, does it only work then if you're going up by 1? Maybe that only works if you're going up by 1. Huh. What if we're skip counting here? What if I want to add the even numbers through 20? So 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20. All right, this is not going to work this time, right? Because we're now going up by 2. Or is it still going to work? 2 plus 20, 4 plus 18, 6 plus 16, 8 plus 14. Huh. How many sums of 22 do we have there? So 5 times 22. What we need to come up with, though, is a formula. What is the pattern here? There's a formula or a theorem we gotta. Because what if I wanted you to add the first 500 terms of a sequence? Okay, so instead of making all these pairs and saying, okay, there's a pair here, there's a pair there, and what's the first and the last term? Okay, what's that? Okay, so how do we write that as a formula? What represents the number of terms that we're adding up, do you think? N. Okay? The number of terms we're adding up is going to be n. What's the first term of a sequence? A sub 1. Now, there isn't a last term of a sequence because it goes on forever, but there is a last term. For example, if we're adding up the first 50 terms, then there is a 50th term. There's an nth term at the end, right? Yeah. We're going to learn about that in a second too. We're going to do this using sigma notation. Okay. Here's the formula. S sub n means the sum of however many terms are going to be adding up. S sub n Now, we always added the first and the last term together, right? A sub 1 is the first term. A sub n would be the last of however many terms we're adding. But then we multiplied that by what? The number of terms, which is n, divided by 2. The sum of an arithmetic sequence, or the partial sum, I should say, of an arithmetic sequence, is the first term plus the last term multiplied by however many terms you're adding up divided by 2.
So where did we get the A from? Like, did he like just plug in our own whatever?
Well, A sub 1 is just in general the first term of whatever sequence you're adding. Okay? And a sub n would be the last that you're adding. Let's test this. Example 3. Find the sum of the first 50 odd numbers. So the first 50 odd numbers. So if we're going to use this little partial sum formula, the sum is equal to, now obviously what's the first odd number? 1. But we got to be careful. We need to write 50 odd numbers in a row. So is the 50th odd number 49 or is the 50th odd number 51? What's the 50th odd number?
40.
Is it 49 or 51? We have to be careful here.
No, it's neither. It's like twice that. It's like,
Or is it 101? Is it 547? Well, this is just something that you should always remember. What's a teeny little formula that generates odd numbers every time? Odd numbers. 2n minus 1. 2n minus 1 generates odd numbers. Because 2n will always give you an even number, right? 2 times n is always an even number. If you subtract 1 from that, that's going to be, it's always going to be an odd number. So the sum of the first 50 odd numbers, what's the 50th odd number? 99. Yeah.
2 times 1 minus 1 would be 0.
Say that again.
2 times 1 minus 1 is 0, and it's not odd.
It's okay. It's okay. What is that last term? Did we agree on what the last term is? 99, right? Or the last odd number that's the first 50. And then we have to multiply that by 50 over 2. We're adding 50 odd numbers, but we divide that in half. So this is 99 plus 1 is 100. And we multiply that by 25. 100 plus, or 100 times 25 is. So the sum of the first 50 odd numbers is 2,500. Now, before the bell rings, just for the sake of practice, express this. Let's consider this a part B. Express this using, somebody brought this up a second ago, and I'm glad they did. Sigma notation. Express this using sigma notation. So, oh geez.
Teachers, we need all help squad members to be excused to go to the auditorium at this time.
No, you don't. So we're starting with n equals 1, and how many terms are we adding up? We're adding 50 terms together, so there needs to be a 50 on top. We're starting with n equals 1 all the way to n equals 50. And what's the explicit formula that determines odd numbers? Starting with 1. 2n minus 1. So that would be the same thing here expressed using sigma notation. N equals 1 to 50 of the formula 2n minus 1.